Okay, we are doing the next assignment, which I think is 4.2. We need to think back to when we graphed linear equations. So if I had y equals 2x minus 5, so that line starts on the y-axis at negative 5, and you're gaining essentially $2 a day. So let's say you owe your parents $5, and you're going to gain $2 a day. To graph that, you go up 2 over 1, up 2 over 1, and you get this line here. And the reason that line is straight is because the increase is constant. We're doing the same number every day. Plus 2, plus 2, plus 2, plus 2. We could also graph a slope in fraction form. So this would be the starting point of positive 1, and then the slope is down 2 over 3. So down 2 over 3, down 2 over 3. We end up with that line. You've worked on those for a couple years. Now we're going to branch off and do exponential equations where we multiply by the same number. These linear equations follow the form y equals mx plus b, where this is the start amount and this is our increase or decrease. I'm going to use the same variables for an exponential equation. It's just set up a little bit differently. Y equals b times m to the x, where this number is our start and this is our increase or decrease, and then that is our time. So a pretty simple one would be y equals 3 times 2 to the x. And if I were to put that in a table, if x is 0, then 2 to the 0 is 1, and 3 times 1 is 1, so I get 3. If I plug in 1, that gives me 2 times 3, which is 6. If I plug in 2, I get 2 squared times 3, which is 12. And 3 will give me 24, and 4 will give me 48. What is that graph going to look like? Is it going to be a straight line? No. So if I graph it, and I start at 3, and then on 1 I go up to 6, and then at 2 I'm at 12, and at 3 I'm at 24, which is probably about there, and I get this graph, which kind of looks like that. Why is it curving taller and taller and taller? I'm doubling. So the first day I went from 3 to 6, so I increased $3. The next day I went from 6 to 12, so I increased $6, and then $12, and so on. So I'm increasing at an increasing rate. And that's how exponential equations work. You're always going to get steeper and steeper and steeper. Well, there's another form of an exponential equation called exponential decay. This one is called exponential growth. But what if my equation was 200 times 0.5 to the x? So I start here at 200. What happens when I multiply 200 by 0.5? It shrinks to 100. And then what happens when I multiply that by 0.5? Shrinks to 50. And then that one goes to 25. And then the next one is 12.5. And I get this. That is called exponential decay. So on one of the problems today, you'll have to state how much did we start with? What's the y-intercept? Is this growth or decay? And how much are you changing by? And it's the change that's a little bit difficult. So you'll get a problem that says something like this. You start with $50 and you're growing at 4% for 10 years. How much will that money be worth after 10 years? The equation is y equals b times m to the x. So that number goes here. But how do we increase by 4%? This is a little bit difficult. How do we increase by 4%? Anybody know? Not 4. So we're going to take 50 and we're going to times it by 4%. But what is 4% as a decimal? 0.04. 0.04. So in my calculator, 50 times 0.04 is 2. So this equals 2. What do I do with that 2? I add it to 50. And I get 52. Okay? But that's only for 1 year. Right? We need to do that 10 times. Nobody wants to do that, right? So you would have to do 50 times 0.4 is 2 plus 50 is 52. Now what? 52 times 0.4, get your answer, add that to 52, and you need to do that 10 times. So we don't want to do it that way. In fact, I can go straight from this number to that number in one step. Okay? And here's how it works. This right here is 100% of my start. So this formula says I want to do 4% and 100% at the same time. What is 100% plus 4%? 104%. So I'm just going to do 50 times 1.04. So 50 times 1.04 is error. What did I do wrong? Oh, 50 times 1.04 is 52. Do you see that shortcut? So what if I want to do this 10 times? Then I could just list it 10 times, or if I'm lazy, just go to the 10th power. So I'm going to do 1.04 to the 10th. And I'm going to skip all that work in between. So here's the hard part. How do you go up 4%? 100% plus 4% is 104. Turn that into a decimal, 1.04. Does everybody understand that? And then I can just ask my calculator, what is 50 times 1.04 to the 10th? And in one step, I can do all of those calculations at the same time. So let's work a couple of these. What if I had $250 and I wanted to go up 12% for 13 years? So y equals b times m to the x. This number is always the starting amount, 250. How do you go up 12%? Good. 100 plus 12 is 112, and then I move the decimal twice. 1.12 to the x, but in this case x is 13, and that will do all 13 years in one step. And that $250 will grow to be almost $1,100. Okay, I'm going to throw a little bit of a curveball to you. What if I had $300,000 that was growing at 3.25% for 40 years? So 300,000 goes here. What do we multiply by? Good. So you always take 100 minus that, or sorry, plus that, which is 103.25, and then we move that decimal twice, and I get 1.0325 to the 40th. So 300,000 times 1.0325 to the 40th. So that's a really good question. This is a percentage. We cannot calculate with percentages. We can only calculate with decimals. So this percentage is equivalent to this decimal. And our calculator does not work with percentages. It only works with decimals. So you have to add it to 100 and then move the decimal twice. Okay, let me throw something else at you that's a little bit different. Let's say you buy a brand new truck for $65,000. Okay, the value of the truck drops 12% each year. How much will the truck be worth in 5 years? How would you drop 12%? Well, how would you add 12%? You would take 100 plus 12. So instead of 100 plus 12, we're going to do 100 minus 12. So 100 minus 12 is 88%, which is 0.88. What does 0.88 mean? That's how much you get to keep. So if you lose 12% of your value, you keep 88%, and that other 12% just disappeared. It's gone. So the formula would be our starting amount times our increase or decrease calculator, 65,000 times 0.88 raised to the, what I say, 5th. And in 5 years, the truck is now worth $34,000. All right. What if you had $120 in the bank and it's dropping at 3% per year for 10 years? How would you do that? Y equals 120 times 0.97. If you lose 3%, you keep 97% and raise that to the 10th. Okay? Let me pull up your ALEKS assignment to show you what they'll look like. And there's just a couple more things you need to learn. Oh. Okay, here we go. So this first problem's pretty straightforward. We're going to take 290,000 people, and the population of the city is increasing by 8.75. So we take 100%, we add it to 8.75, and I get 108.75%. To turn that into a decimal, I move the decimal 2 places And we have 1.0825. And this is going to take place, 0.75, thank you, for 6 years. So 290,000 times 1.0875 to the 6th. Oh, I messed up again. I'm sorry. There we go. So this says round to the nearest person. Why? Because you can't have, even short people are a full person. Right, Kara? We're full people. Okay, what if the problem said, instead of growing, what if it was decreasing by 0.875? Then you would do 100 minus 8.75, and I get 91.25, and I turn that into a decimal, and I would put 0.9175 and then raise that to the 6th. So if you're going up, your rate is 100% plus the interest rate. If you're going down, your rate is 100% minus the interest rate. Okay. Let's look at number 2. Number 2 is a little bit different. It says you borrow $14,000 and the interest rate is 5.75 and you don't make any payments. How long is it going to take before you owe $23,000? So if you go to the bank and borrow money and you don't make any payments, every day they're going to add a little bit of interest onto the loan. How many years is it going to take before you owe $23,000? So we write out the equation. Y equals 14,000 times 100 plus 5.75 is 105.75. And then we move the decimal 2 places. And I get 1.0525 to the x. And our job is to figure out what x value is it going to take before we break the 23,000 mark. So really the best way to do this is kind of just guess. So we plug it in the calculator. So 14,000 times 1.0525. And how long do you think it's going to take? 20 years. Let's try 20 years. And I'm looking for 23,000. Did we go too long? Yes. So you can retype all that if you want, but a lot of calculators will let you pull up your previous value. On the TIs, if you do second enter, like the ones on the wall, if you push second enter, it will bring up the last equation. So let's try 10. 10 was a little bit too many. So now let's try 5. 5 was not enough. And the correct answer is the smallest number that is bigger than 23,000. So 5 was not enough. Let's try 6. 6 is not enough. So let's try 7. 7's not enough. Let's try 8. Still not enough. 9. Oh, so it is 10. So 10 is the smallest number that breaks the 23,000 mark. Does that make sense? And really, right now, the only way to figure that out is just guess and check. So just guess around until you find the smallest number that creates a number larger than 23,000. Okay. Number 3. So number 3 gives you an equation and it wants you to figure out what's happening here. So this is the population of a small city. Population of the number of fish in a lake. How many fish are in the lake right now? Just looking at the equation. 200. Is this population getting bigger or smaller? Bigger. How can you tell? That number's bigger than 1. What is the increase rate? How fast is the population growing? 38%. Okay. What if I had this? The initial population is still 200. Is that growth or decay? Decay. How fast is it decaying? 8%. So if you get to keep 92%, that means you lost 8%. Number 4. Okay, we have a forest that covers an area of 1,500. The area is decreasing by 4.4%. What is the equation? And it wants you to use the variables y and t. So y equals, the starting amount is 1,500. What number do I plug in for a decrease of 4.4? 100% minus 4.4% is 95.6%. Move the decimal twice. 0.956 to the t. That's it. Get to work.